Good morning, class. This is the ECON 512 Introduction to International Trade class. Today is January 25th, 2022, Tuesday. The class will cover the second part of Chapter 3. As you remember that the Chapter 3 topics are the traditional international trade theory developed by Adam Smith's model, and also we discussed the comparative advantage as a basis for the international trade developed by David Ricardian's model, as well as general equilibrium solution model of the classical model. And today we are going to discuss the gains from international trade of the country and trade and wages. And also we are going to discuss the evaluation of the classical model. So this is the first video clip I developed. So let's watch.
Hello. In this video we're going to review the basics of trade, talking about issues such as comparative advantage, specialization, and we're going to start this example by assuming we have two countries, the United States and Japan. Each country can produce two goods, grain and steel. The United States, production possibilities frontier is given up here in the top left. If we allocate all our resources to producing nothing but grain in the United States, we could produce 100 units of grain. If we allocate all our resources to the production of steel, we could produce 50 units of steel. We're going to assume that the United States will produce a combination of grain and steel where we're producing 60 units of grain and 20 units of steel, a point on the PPF curve. Japan likewise can produce grain and steel. If Japan allocates all its resources to grain production, it can produce 40 units of grain. If it allocates all its resources to the production of steel, it can produce 40 units of steel. We're going to assume that Japan locates on its PPF at a point right here, highlighted by this point, which corresponds to 30 units of grain and 10 units of steel. Usually the first thing we want to do in these types of problems is figure out who has a comparative advantage in which good. The way to do that is to construct a simple table, like I've shown here. And we're basically trying to calculate the opportunity cost of producing one more unit of something. In this case, one more unit of steel and one more unit of grain, the two goods in question. So in this first column here, I have the opportunity cost of producing one more unit of steel. In the United States, the opportunity cost of producing one more unit of steel is going to be 2 units of grain. In other words, every time we produce one more unit of steel in the United States, the cost comes in giving up the opportunity of producing 2 units of grain. The way I calculated that answer is by using that formula that I talked about in the previous video, where we take what you give up and divide it by what you get. In the United States, what we give up in producing steel is 100 units of grain. What do we get? 50 units of steel. So 100 divided by 50 is where the answer 2 is coming from. In Japan, we're going to calculate the opportunity cost the same way. In Japan, what we give up if we're producing steel is 40 units of grain. What do we get in return? In Japan, if we give up producing 40 units of grain, what do we get? 40 units of steel, so 40 divided by 40 is just 1 unit of grain. So maybe I'll just write that here. And that's where the 2 came from. Now, to examine the opportunity cost of producing the other item, in this case grain, it's what you give up divided by what you get. If we're producing nothing but grain in the United States, we're giving up producing 50 units of steel. What are we getting back? The 100 units of grain. 50 divided by 100 gives us the opportunity cost of 1/2. Every time we produce one more grain, in other words, one more unit of grain, in other words, we give up producing 1/2 unit of steel. For Japan, if we're producing nothing but grain, we are producing, we're giving up producing 40 units of steel. We're getting 40 units of grain, so the opportunity cost is 1 unit of steel. Every time we produce one more unit of grain in Japan, we always give up producing 1 unit of steel. So given these values, these numbers, we can now calculate comparative advantage. So let's see who has a comparative advantage in which good. In terms of producing steel, it looks like Japan has a comparative advantage in the production of steel. Every time Japan produces one more unit of steel, it only gives up 1 unit of grain. But the U.S. gives up 2 units of grain. Therefore, Japan is has a comparative advantage in steel production. So let me note that here. Japan's comparative advantage, CA, is in steel production. 1 is less than 2. Now let's see about the production of grain. Who produces grain at the lowest opportunity cost? Well, it appears that the U.S. has a comparative advantage in grain production. Every time you produce one more unit of grain in the United States, you're only giving up 1/2 unit of steel, while in Japan you would have to give up a full unit. So the United States, U.S., has a comparative advantage in grain production. In these problems, then, generally what we're going to do next is we're going to assume that each country is going to completely specialize in their comparative advantage, and then they're going to trade with the other country for the good that they don't have a comparative advantage in. So let's go through that analysis now. To finish up this video, I want to show how both countries can benefit from comparative advantage, specialization, and trade. We're going to have a table here at the bottom with several columns. The first set of columns shows the situation, should be without trade. Let me put a O there, without trade. Assuming that the United States and Japan are self-sufficient, not trading with one another, we can assume that the U.S. is going to produce and consume 60 units of grain and 20 units of steel. We're also going to assume that Japan is going to produce and consume 30 units of grain and 10 units of steel. Note at the beginning of the video I illustrated where those points were located along the production possibilities frontiers. Now we have a next set of columns here that I'm calling the specialization columns. You can assume that each country is going to specialize in their comparative advantage. In the United States case, they're going to do nothing but produce grain. Grain, after all, is what we argued is what the United States has a comparative advantage in. So the United States will produce 100 units of grain, and if the U.S. is producing 100 units of grain, can't produce any steel. Japan is going to specialize in its comparative advantage, which we argued is steel production. So Japan at most can produce 40 units of steel, and if it's producing 40 units of steel, it can't produce any grain. Now what we want to do is to come up with some terms of trade that will basically make both countries better off. So one such terms would be that the United States trades 35 units of grain for 25 units of Japanese steel. So once again, the terms of trade might be that the United States is going to trade 35 units of grain for 25 units of Japanese steel. So if the United States trades away 35 units of grain, it'll have 65 units of grain. Just simply 100 minus 35. What does the United States get back? Well, according to the terms of trade, it'll get back 25 units of steel. Now, from Japan's perspective, Japan is receiving 35 units of grain. Okay, it wasn't producing any grain while it was specializing, so it's going to get 35 units of United States grain. What does it cost Japan to do that? Well, Japan has to trade away 25 units of steel. So 40 minus 25 is 15. Let's examine these trade numbers here at the end. With trade, the United States is consuming 65 units of grain and 25 units of steel. What's interesting about that point, it's going to be a point outside the United States production possibilities frontier. With trade, a country can consume beyond its PPF. Japan, the same thing. This consumption point of 35 units of grain and 15 units of steel is going to be a point that is outside Japan's production possibilities frontier. Trade allows us to have a much larger level of consumption than otherwise would be the case if we were simply self-sufficient. The last thing I want to do in highlighting the benefits of trade is to show you that the U.S. is buying a unit of steel for 35 divided by 25, what you give up divided by what you get again, for only 1.4 units of grain. So the U.S. is buying a unit of steel, in essence, for 1.4 units of grain. If the United States was self-sufficient and didn't trade, it would cost the United States 2 units of grain to produce 1 unit of steel. So the United States is clearly benefiting from this. It's cheaper for the United States simply to buy steel from Japan than to produce it for themselves. In Japan, the same thing. Japan is buying 1 unit of grain for 25 divided by 35, what you give up divided by what you get, or 0.71 units of steel. It costs Japan 1 unit of steel to produce 1 unit of grain. So it's simply cheaper for Japan to get its grain from the United States than to produce it for itself. Okay, I hope you found this video helpful.
Hello and welcome to today's economic lesson on Easy Peasy Learning 101. You probably ask yourself why countries should trade with each other. That is a very good question and we hope to clear that up. Or you just heard about the Ricardian Model and you want to know what it is. Enjoy the video. There are several reasons for countries to trade with each other. First of all, the price of a good goes down when it's produced in higher quantities. That is called mass production. Furthermore, we have to consider that in different countries there's a difference in climate, labor and technology, which has a crucial influence on the price and production of goods. It will be easier to understand if we take a look at an example. Let's take 2 countries which are specialized on specific goods. Our first country is Germany, which produces cars, and the other country is the USA, which produces mobile phones. We assume that Germany needs 20 hours to produce 1 unit of cars and 10 hours per unit of mobile phones. The USA, on the other hand, needs 30 hours to produce 1 unit of cars and 5 hours to produce 1 unit of mobile phones. So we can see that Germany is able to produce the same amount of cars in a shorter time, and the USA needs, in comparison to Germany, less time to produce a unit of phones. In conclusion, we can say that both countries have the absolute advantage on a specific good. Absolute advantage is the ability of a country, individual, company or region to produce a good or a service at a lower cost per unit than the cost at which any other entity produces that same good or service. That is the reason why Germany and the USA in our example concentrate on producing the good where they have the absolute advantage. If we now look at the cost for each country to produce 50 units of the 2 goods each, we can see that both together have to invest 3,250 hours altogether. This situation can be optimized by trading. Let's see why. Now Germany produces only cars, and the USA produces only mobile phones. To produce the same amount in the end, the countries have to produce 100 units of their respective products. If the countries decide to trade, they only need 2,500 hours to produce the amount which they needed 3,250 hours for earlier. With trading, the 2 countries can save 750 hours, which is a huge economic advantage. That is what Adam Smith found out in the late 18th century. To explain the Ricardian model, we assume that one country has the absolute advantage in producing both goods. As our example products, we look at the production of sausages instead of mobile phones. We see that Germany can produce both goods in a short amount of time per unit. Germany has the absolute advantage in both goods. Now we have to use math to determine which product each country should produce. For every good, we divide the amount of hours per unit for that good by the amount of hours per unit of the other good, which the country could produce. The good with the smaller ratio is the good the country should be producing. In comparison with the other result of the country, it shows us the comparative advantage. Comparative advantage is the ability of a country to produce a good or service at a lower opportunity cost than its competitor. To come back to our example, Germany sacrifices less to produce sausages than it would producing cars, and the USA sacrifices less to produce cars than producing sausages. In general, the opportunity cost shows us what a country sacrifices when they choose one good over another. If we now look at the individual production of this example, we have a total cost of 4,250 hours to produce 50 units of each good for each country. This situation is not optimal and can be improved if the countries trade. Germany has the comparative advantage on producing sausages and the USA on producing cars. Both countries produce only the good on which they have the comparative advantage. The cost for 100 units of the good is 3,500 hours. Now we save 750 hours, which proves that trading makes sense, although a country holds the absolute advantage in both goods. That was the Ricardian.
If you haven't watched the first video for Chapter 3, please do that now. Otherwise, you'll have difficulty understanding the algebraic approach used here. Here's a quick review of our example. There are two countries, the U.S. and Canada. Each country can produce two goods, bread and steel. Canada is more productive in bread production, but the U.S. is more productive in steel. The opportunity cost of one more ton of steel is the number of loaves of bread that will not be produced because of higher steel output. And the opportunity cost of one more loaf of bread is the number of tons of steel that will not be produced because of higher bread output. In this case, producing one more ton of steel in the U.S. costs 0.67 loaves of bread. Producing one more ton of steel in Canada costs 3 loaves of bread. The cost of producing steel in the U.S. is lower than in Canada. The U.S. has a comparative advantage at steel production. Similarly, producing one more loaf of bread in the U.S. costs 1.5 tons of steel. Producing one more loaf of bread in Canada costs 0.33 tons of steel. Canada has a comparative advantage at bread production. Why does Ricardo's scheme work? Algebra. Define the barter price of bread in the U.S. as the number of tons of steel it takes to buy a loaf of bread. The barter price of steel in the U.S. has a similar definition. It costs the U.S. 1.5 tons of steel to produce a loaf of bread. The cost of producing one more ton of steel is the reciprocal of 1.5, which is 2/3 or 0.67 loaves of bread. And of course, there are barter prices of bread and steel in Canada. It costs Canada 1/3 ton of steel to produce one loaf of bread. The cost of producing one more ton of steel is, again, the reciprocal of 1/3, 3.0 loaves of bread. Ricardo's remarkable result implies that every country, individual, and business firm must have a comparative advantage at some productive activity. For example, Professor Gerber has a comparative advantage at writing international economics textbooks. If the U.S. can sell a ton of steel for more than 0.67 loaves of bread, it will be better off. If Canada can buy a ton of steel for less than 3 loaves of bread, it will be better off. These two prices form the bounds on the world price. If the world price of steel is less than 0.67 loaves of bread, no one will make steel. If the world price is above 3, no one will make bread. Suppose the world price is 2 loaves of bread per ton of steel. This defines the slope of the consumption possibilities curve, CPC, the price at which one good can be traded for another on global markets. In this case, the slope of the CPC is -2. This is the rate at which bread and steel can be traded. To acquire a ton of steel, either country can give up 2 loaves of bread. The U.S. will produce only steel. Each ton of steel can be used to obtain 2 loaves of bread. This is far better than the 2/3 of a loaf of bread that could be obtained under autarky. Canada will produce only bread. Each loaf of bread can be used to obtain 1/2 ton of steel. This is far better than the 1/3 ton of steel Canada could produce under autarky. Both countries will be better off because of specialization in trade. Each will consume above its PPC. In 1817, David Ricardo published his groundbreaking paper on the principles of political economy and taxation. Ricardo laid out the principle of comparative advantage and illustrated it using a simple example that is still used today when teaching this subject. Before Ricardo, the predominant theory of international trade was mercantilism based on absolute advantage. Ricardo showed that 2 countries could gain from trade even if one of them had an absolute advantage at producing every product. Intuitively, it is inefficient for one country to produce everything and the other country to produce nothing. Here are the assumptions of the simple Ricardian trade model. Labor is the only input to production. Labor is immobile. It cannot migrate across borders. However, within a country, labor is completely mobile between industrial sectors. Labor is fully employed. Regarding markets, we assume 2 outputs, perfectly competitive markets, and no transportation, trade, or other transactions costs. Technology exhibits constant returns to scale, and we assume no changes in technology or skills. Labor productivity is defined as units of output divided by hours worked. For example, if 4 loaves of bread can be produced by 1 worker in 2 hours, labor productivity is 2 loaves per hour. We usually assume output prices reflect costs. We use the terms price and cost interchangeably. Assume there are 2 countries, the U.S. and Canada, and there are 2 goods, bread and steel. Productivity in each country is summarized in this table. Canada has an absolute productive advantage in bread production, but the U.S. has an absolute productive advantage in steel. The production possibilities curve, PPC, shows the combinations of 2 goods a country can produce given current technology and available resources, labor, capital, raw materials, etc. The PPC for the U.S. shows the combinations of bread and steel that the economy can produce. Points like B that lie on the PPC are efficient. All resources are being used to produce the largest possible quantities of bread and steel. This is often called full employment output. Remember, in economics, cost means opportunity cost, what is given up to increase another activity by 1 unit. The slope of the PPC tells us how many loaves of bread we must give up to produce 1 more ton of steel. In other words, the slope of the PPC is the cost of producing 1 more ton of steel in units of loaves of bread. Points like A that lie below the PPC are inefficient. Some resources are not being used. The quantity produced of, say, bread can be increased without decreasing output of the other good. We often say there are unemployed resources. Points like C that lie above the PPC are infeasible. Given currently available resources and technology, those quantities of bread and steel cannot be produced. The only ways to achieve output above the PPC are to acquire more resources and/or improve technology. The consumption possibilities curve, CPC, shows the quantity of bread needed to buy 1 more ton of steel at the world price. The U.S. can sell steel and buy bread at world prices, allowing it to consume at points along the CPC. However, it would be foolish to consume on any point such as X. That point lies below the PPC. The U.S. would be better off just consuming on the PPC instead of trading to point X. If the U.S. chooses to trade, it can move up the CPC, trading each ton of steel for 2 loaves of bread. Compare trade with autarky, the complete absence of trade. Under autarky, each country can only consume what it produces. Trade is better than autarky. Under autarky, giving up a ton of steel only produces 2/3 of a loaf of bread, but with trade, giving up a ton of steel produces 2 loaves of bread. In effect, the U.S. can consume outside its PPC by trading. Why would the U.S. produce any bread at all? If the U.S. produced only steel, it would trade at 2 loaves of bread per ton. Every ton of steel not produced by the U.S. creates only 2/3 of a loaf of bread. The U.S. should completely specialize in steel production. Production will be at point B. By producing at point B, the U.S. can trade along CPC prime to a point like C. Note that economic welfare has unambiguously improved because consumption of both goods has increased. Production at point B maximizes U.S. income because the CPC line at that point is the farthest possible from the origin while still in contact with the PPC. Point C is clearly superior to any point on either the PPC or the original CPC that passes through point A. At point C, more of both goods is being consumed, an unambiguous improvement in economic welfare.
In the last lesson, we introduced the concept of comparative advantage and showed how two players with different opportunity costs could cooperate, specialize, and trade, and both be better off. In this lesson, we'll give another illustration of the concept of comparative advantage. This one is a story about international trade, and we'll show how two countries with different opportunity costs for producing two products can specialize and trade and both be better off. Let's look first at the country of Pakistan, and we'll suppose that Pakistan uses one input, labor, to produce two outputs, two agricultural products, wheat and rice. We'll begin with a description of Pakistan's technology. Suppose that the unit labor requirement for producing one good, wheat, is 2 workers. That is, in Pakistan, it takes 2 workers to produce 1 bushel of wheat. Suppose also that the unit labor requirement for rice is 3 workers. It takes 3 workers to produce 1 bushel of rice. Now, if this is the case, the opportunity costs can be calculated from the unit labor requirements. That is, if you want to produce a bushel of rice, it's going to take you 3 workers. Those 3 workers divided by the 2 workers that are needed to produce a bushel of wheat let you know that any time you produce 1 bushel of rice, you are giving up 1.5 bushels of wheat. The opportunity cost in Pakistan to produce 1 bushel of rice is 1.5 bushels of wheat. Now, let's introduce the constraint on Pakistan's production. Suppose that there are 60 workers in Pakistan. These 60 workers can be used to produce wheat, or they can produce rice. But the amount of wheat and rice that can be produced will be limited by the technology. In particular, suppose we take those 60 workers and divide them by the 2 workers that are needed to produce 1 bushel of wheat. The total amount of wheat that can be produced in Pakistan in a given period of time is 30 bushels of wheat. 60 workers divided by 2 workers per bushel of wheat equals a total of 30 bushels of wheat, the maximum wheat output possible in Pakistan. Suppose instead all 60 workers are used to produce rice. Divide 60 workers by 3 workers per bushel of rice, and you get a maximum output of 20 bushels of rice. Therefore, we've got the constraints on production possibilities in Pakistan. 60 workers, 2 workers per bushel of wheat, 3 workers per bushel of rice. We're ready now to draw a production possibilities frontier for Pakistan's economy. But before I do that, let me go ahead and introduce a potential trading partner for Pakistan, and that is Malaysia. Malaysia is going to have a different technology, and this different technology will become the basis for trade between Pakistan and Malaysia. Let's suppose that in Malaysia, it takes only one worker to produce a bushel of wheat. Notice that Malaysia has an absolute advantage in the production of wheat. That is, Malaysia can produce wheat with fewer workers than it takes to produce wheat in Pakistan. Malaysia is therefore better at producing wheat. They can make more with less, and therefore we say Malaysia has an absolute advantage in the production of wheat. Likewise, it takes 2 workers to produce 1 bushel of rice in Malaysia. Therefore, we say that Malaysia also has an absolute advantage in the production of rice. It only takes 2 workers to produce a bushel of rice in Malaysia. It takes 3 workers to produce a bushel of rice in Pakistan. Because Malaysia can do more with less, we say that Malaysia has an absolute advantage. Notice the way I've set up this example. I've cooked up a case where Malaysia has an absolute advantage in the production of both goods. Economists like examples that work like this. We like to show you that even though Malaysia is better at doing everything, that is, even though Malaysia can produce more wheat and more rice with a given amount of labor than Pakistan, in the end, we will find that it is still advantageous for Malaysia and Pakistan to cooperate and trade. Even though Malaysia has an absolute advantage in the production of each good, it will still turn out that Pakistan has a comparative advantage in something. Now, let's suppose then that these numbers represent technology in Malaysia. What is the opportunity cost for Malaysians of producing a bushel of rice? Well, if they produce a bushel of rice, they are going to need 2 workers to do so. And those 2 workers divided by 1 worker needed per bushel of wheat means that in Malaysia, anytime you're producing 1 bushel of rice, you are giving up 2 bushels of wheat. The opportunity cost in Malaysia of producing 1 bushel of rice is 2 bushels of wheat. Now, in a minute, we're going to compare Malaysia's opportunity cost with Pakistan's opportunity cost to calculate comparative advantage. But first, let's look at the constraints on the production possibilities in Malaysia. Suppose there are 60 Malaysian workers, and they can spend their time either producing wheat or rice. What's possible in Malaysia? If you take the 60 workers and divide by 1 worker needed per bushel of wheat, you get the total maximum wheat production possible in Malaysia is 60 bushels of wheat. 60 workers at 1 worker per bushel gives you a maximum output of 60 bushels of wheat. Likewise, if those 60 workers go into the production of rice instead, 60 workers divided by 2 workers per bushel of rice gives you a maximum rice output possible of 30 bushels. Notice that because Malaysia has lower unit labor requirements, Malaysia can make more output with its 60 workers than Pakistan can. Now, given these numbers, we can write out a table of the production possibilities for Pakistan and for Malaysia. Let's look at those tables now. First, we'll look at the production possibilities for Pakistan. If Pakistan has 60 workers, then it's possible for Pakistan to produce any combination of wheat and rice given in this table. Pakistan can use all of its workers in wheat and produce no rice. Pakistan can produce 20 units of wheat, moving some workers into the production of rice. It can produce 15 and 10, 10 and 13 and a third, and so forth. Any of these combinations is possible. Remember, anytime Pakistan wants to produce an extra unit of rice, it has to move 3 workers into the production of rice. Those are 3 workers that are not available for wheat production. And 3 divided by 2 workers needed per bushel of wheat means that any time Pakistan produces 1 extra bushel of rice, it's giving up 1.5 bushels of wheat that it might otherwise produce. So we will use these numbers in a moment when we draw the production possibilities frontier for Pakistan. Notice, as you look at these numbers, these are the production possibilities. We'll move this number over to the board. And we'll look at the production possibilities now for Malaysia. Notice the numbers are bigger because Malaysia has an absolute advantage. It is more productive than Pakistan with its labor. Here are all the possibilities, 60 and 0, 40 and 10, 20 and 20. I say all, these are some. What I mean is all of these combinations are possible with 60 workers and Malaysia's technology. Notice that the opportunity cost of producing 10 bushels of rice is 60 minus 40, or 20 bushels of wheat that Malaysia has to give up. As we saw before, anytime Malaysia wants to produce an extra bushel of rice, Malaysia has to give up 2 bushels of wheat. We'll move these numbers now over to the board and use them whenever we plot the production possibilities frontier for Malaysia. Let's go ahead now and plot that production possibilities frontier. The first diagram will represent the production possibilities of Malaysia. The second set of axes will represent the production possibilities of Pakistan. Now, we've got to label the axes carefully or the diagram doesn't mean anything. So let's put wheat on the vertical axis in each case, and we will put rice on the horizontal axis in each diagram. Now we are ready to draw the production possibilities frontiers, and we have 2 options. The first option is to plot points directly from the schedules that are over on the board. That's easy enough to do. So we could start with Malaysia's. Malaysia, if they produce only wheat, can produce up to 60 bushels of wheat. So I'll go up here to the point 60. That leaves them no labor for producing rice. So we have this point, 60 and 0. If they use all of their labor to produce rice, they can produce 30 bushels of rice and no wheat, so that would be this point, 30 and 0 on the horizontal axis. And then we could just go through and plot other combinations, like 40 and 10, 20 and 20, 10 and 25, and so forth on down. Once we have plotted all of these points, we can connect them in the diagram and draw the production possibilities frontier. Now, I didn't go through and plot all of those points because I don't want to make my diagram too cluttered. But it's clear to you that you could plot all of these points and then just connect them with a straight line. Notice the production possibilities frontier will be a straight line in this case. You'd find that out if you plotted all of the points. What does it mean? What does it mean that the production possibilities frontier for Malaysia is a straight line? It means that the opportunity cost is constant. Anytime Malaysia wants to produce an extra bushel of rice, it has to give up 2 bushels of wheat. If Malaysia wants to move 1 more bushel of rice outwards in the horizontal axis, then it has to move down 2 bushels of wheat. And that doesn't matter whether it's producing its first bushel of rice, its 10th, or its 30th bushel of rice. Every bushel of rice in Malaysia has the same opportunity cost of 2 bushels of wheat. That's why the slope of Malaysia's production possibilities frontier is constant at -2. There is no increasing opportunity cost. Opportunity cost is constant for Malaysia, and that means that all resources that are used to produce wheat and rice are equally well suited to the production of either good. There is no kind of specialization or special characteristics of resources. All resources are equally well suited, and that's why the opportunity cost is constant and the production possibilities frontier is a straight line. Alternatively, if we hadn't wanted to use the numbers and plot the points from over in the diagram, we could have used the formula for Malaysia's production possibilities frontier. This is the formula that I used to get those numbers to begin with. Before I started this example, I wrote down this formula because it's what I wanted my production possibilities frontier to look like. If I'd given you this formula to begin with, you could have simply plotted the equation. Here's the formula for Malaysia's production possibilities frontier. Wheat is equal to 60 minus 2 times the amount of rice that Malaysia produces. I'll move this equation now over to the board, and you can see that the equation is what I've drawn here in this diagram, that the vertical intercept is at the point of 60, the maximum wheat production that Malaysia can turn out if it uses all 60 of its workers to produce wheat. The horizontal intercept is going to be 30. That is, if you plug in 30 for R, the rice production, you get 0 wheat left over to be produced. If all workers are in rice, you get 30 units of rice produced. And the slope of this line is -2. That's the coefficient on rice in the formula. Anytime Malaysia wants to produce 1 more bushel of rice, it gives up 2 units of wheat. So the slope of this line is -2, and I'll go ahead and write that in. -2 is the slope of Malaysia's production possibilities frontier. I can use the same technique now to derive the production possibilities frontier for Pakistan. I know what the endpoints are. The endpoints are going to be 30 bushels of wheat if Pakistan uses all of its labor to produce wheat. I got this number from over in the table. Also, if it uses its labor to produce only rice, then we get 20 bushels of rice. So there's the other endpoint. You could plot some of the intermediate points and you'd see that they lie on a straight line, or you can simply connect the 2 dots at the end and get the production possibilities frontier for Pakistan. So let me draw this line in carefully. There's the production possibilities frontier for Pakistan. The endpoints tell us about the maximum production that's possible if Pakistan completely specializes in one good or the other. That is, the maximum wheat production Pakistan can get is 30 bushels of wheat, and the maximum rice production that Pakistan can get is 20 bushels of rice. I could get the same information if I used the formula for Pakistan's production possibilities frontier. Wheat is equal to 30 bushels, that's the maximum production, minus 3/2 times the amount of rice production. Remember, -3/2 or -1.5 is the opportunity cost in Pakistan of producing another bushel of rice. Anytime Pakistan adds 1 unit of rice to its output, it does so by giving up 1.5 bushels of wheat. So the slope of the curve here is going to be -3/2. That's the opportunity cost of rice measured in terms of wheat that Pakistan would have to give up. Again, notice in Pakistan's case, we have the production possibilities frontier being a straight line, indicating that all resources being used in Pakistan are equally well suited to the production of rice or wheat. So here we have our situation. Here are Malaysia's production possibilities, and here are Pakistan's production possibilities. If now these 2 countries wanted to produce independently of each other, that is, if we have them separated so that they can't trade, then we could pick a point on each production possibilities frontier and call that the consumption point in the separated economies. Let's suppose that Malaysia cannot trade with Pakistan. If Malaysia cannot trade with Pakistan, then all of the consumption possibilities lie on this curve too. If Malaysia is going to eat some combination of wheat and rice, then it has to make that combination of wheat and rice for itself. And let's suppose that the mix that they choose is a mix like 20 and 20. That is, Malaysia chooses to produce at this point right here with equal quantities of wheat and rice produced. So here we have 20 units of rice, 20 bushels of rice produced in Malaysia, and 20 bushels of wheat produced in Malaysia. This combination 20 and 20 is one of Malaysia's production possibilities, and it's the production possibility that we are going to imagine that Malaysia chooses if they have to produce on their own. We can say the same then about Pakistan. Pakistan has this table of production possibilities, and if it wants to operate by itself without trade, it's got to choose some point on this line, and that be its consumption. So let's suppose that Pakistan chooses this point right here, which would be at 15 and 10. I'm going to imagine that Pakistan chooses to produce and consume 10 bushels of rice and to produce and to consume 15 bushels of wheat. So the black dots in each of these diagrams represent the pattern of production and consumption when the 2 economies operate independently of each other. Now, let's show how, by cooperating, Pakistan and Malaysia can improve their situation. How, by cooperating, Pakistan and Malaysia can produce more wheat and more rice than they are producing operating independently. First, let's notice how much that they are producing together when they're operating independently. Malaysia is producing 20 bushels of wheat. Pakistan is producing 15 for a total wheat production of 35 bushels. Malaysia is producing 20 bushels of rice, Pakistan 10, for a total rice production of 30 bushels. Let's see now how by cooperating, specializing, and trading, we can increase the quantity of agricultural goods that the two countries have available. Let's look at an example. In Malaysia, the opportunity cost of 1 bushel of rice is 2 bushels of wheat. The same amount of labor that will produce these 2 bushels of wheat would otherwise produce this 1 bushel of rice. So the opportunity cost can be represented by this ratio. 1 bushel of rice always costs 2 bushels of wheat in Malaysia. In Pakistan, on the other hand, 1 bushel of rice costs only 1 1/2 bushel of wheat. Or we could write this a different way. The opportunity cost of 2 bushels of rice in Pakistan is 3 bushels of wheat. That is, the same labor that could produce 3 bushels of wheat would otherwise be producing 2 bushels of rice. Now, we can show here that there is a possibility of gain from trade. Notice that the opportunity cost of producing 2 bushels of rice, for instance, is lower in Pakistan than it is in Malaysia. If Malaysia wants to produce 2 bushels of rice, it's going to be giving up 4 bushels of wheat. The opportunity cost in Malaysia is 2 bushels of wheat for 1 bushel of rice. In Pakistan, on the other hand, if Pakistan wants to produce 2 bushels of rice, it's only giving up 3 bushels of wheat. That is, the opportunity cost of rice in Pakistan is lower than it is in Malaysia. Therefore, we know, by definition, Pakistan has a comparative advantage in the production of rice because it can produce rice at a lower opportunity cost than can Malaysia. These are the numbers that are in the production possibility frontier equation. Malaysia's slope is -2, that is 2 bushels of wheat for every bushel of rice. Pakistan's slope is -3/2, that is 1.5 bushels of wheat for every bushel of rice. Now that we know that Pakistan has a comparative advantage in the production of rice, we can tell a story whereby Malaysia and Pakistan cooperate to increase their wealth. Here's the way the story works. Since Pakistan has a comparative advantage in the production of rice, Malaysia is going to try to find some way to get Pakistan to want to produce rice and send it to Malaysia instead. Malaysia wants to specialize in the direction of wheat. Pakistan would specialize in the direction of rice. Here's a story that I think will make this comparative advantage comparison clear. Let's suppose that Malaysia wants to try to make things good for itself. What it will do then is it will cut back its production of rice by 2 units. So get these 2 bushels of rice off the board and replace it with 4 bushels of wheat. That's what Malaysia can produce instead. Now, Pakistan down here is producing 3 bushels of wheat. But remember, Pakistan has a comparative advantage in rice, so anything that allows Pakistan to reduce its wheat production is going to increase wealth for these two economies operating together. So let's have Malaysia send these 3 bushels of wheat down to Pakistan, which then allows Pakistan not to have to produce these 3 bushels of wheat. Instead, Pakistan can devote its labor to rice production and increase its rice output by 2 units. So now that Pakistan has someone else producing wheat for it, Pakistan can produce 2 extra bushels of rice, which it then sends to Malaysia. Notice now we're back where we started. Pakistan has 3 bushels of wheat, which now Malaysia is producing and sending to it. Malaysia has 2 bushels of rice, which it got from Pakistan. But we now have 1 extra bushel of wheat. This extra bushel of wheat was created by specialization and trade. This bushel of wheat did not exist before. We're back where we started with 1 extra bushel of wheat. That's what happens when 2 countries specialize in trade. Let's suppose now that since Pakistan has a comparative advantage in the production of rice, that we have Pakistan produce all of the rice for the 2 economies. And let's suppose that in addition, that we have Malaysia produce 12 bushels of rice and spend its remaining labor on wheat. With this particular production of specialization and trade, we can now see that both countries can be better off. Let's look back at our diagram. Here we have Pakistan specialized according to its comparative advantage, producing 20 bushels of rice. Now, these 20 bushels of rice are available for trade, so Malaysia can now change its pattern of production and specialize in the direction of wheat. We're going to have Malaysia cut back its production to 12 bushels of rice, and that leaves 12 times 2 is 24, subtracted from 60 is 36 bushels of wheat that Malaysia can produce. So here's a new point on Malaysia's production possibilities frontier. If Malaysia produces here at this orange point and Pakistan produces here at this orange point, we can see that they have created more wheat and more rice for their combined economy. Let's add up the totals. Pakistan is producing 20 bushels of rice. Malaysia is producing 12 bushels of rice for a total of 32 bushels of rice. They were only producing 30 bushels before. That's 2 extra bushels of rice created by trade. Let's look at wheat production. Well, Pakistan is not producing any wheat, and Malaysia is producing 36 bushels of wheat. 36 is 1 more bushel than we were producing before, when the economies were operating independently and producing only 35 bushels of wheat. Aha! By specialization, according to comparative advantage, we have created an additional 2 bushels of rice and an additional 1 bushel of wheat. These two economies now can agree to trade in such a way that both of them are better off. They can find some ratio of trading rice for wheat that makes them both better off than they were before. Those extra 2 bushels of rice and extra 1 bushel of wheat are available to be divided between Malaysia and Pakistan. And the rate of trade that they will agree on is somewhere between the slopes of their production possibilities frontier. Pakistan is quite happy to trade with any terms of trade that give it more than 1.5 bushels of wheat per bushel of rice. Malaysia is happy to trade with any terms of trade that give it less than 2 bushels of wheat per bushel of rice. So the two economies can now agree upon a particular price of wheat in terms of rice that will allow them both to be better off. By specializing, they have created more wheat and rice together than they could have created separately. And this is the basis of their gains from trade. Notice, each country produced more of the good in which they had comparative advantage, more of the product for which its opportunity cost was relatively low.
Hi. Today we're going to be dealing with one of the deepest ideas in economics, comparative advantage. Comparative advantage is a theory of trade. It explains why people trade and which goods people should trade if they want to maximize their well-being. It's actually useful to understand comparative advantage to begin with a false theory, a very plausible but incorrect theory of trade, namely the theory of absolute advantage. So let's consider a simple model. Let's suppose that labor is the only good used in production and that we can produce computers or shirts. Now let's suppose that in Mexico it takes 12 units of labor to produce 1 computer. And again in Mexico it takes 2 units of labor to produce 1 shirt. Now let's compare with the United States. To make it simple, we'll suppose that in the United States it takes just 1 unit of labor to make 1 computer and 1 unit of labor to create 1 shirt. Now, from the absolute advantage theory of trade, it may seem obvious that there in fact will be no trade here. It may seem obvious that the United States will outcompete Mexico on all margins. After all, the United States, in this example, is much more productive at producing computers and also more productive at producing shirts than Mexico. So this is a case where we might think, well, the United States is so much better at producing both computers and shirts that certainly there's no reason for the United States to trade with Mexico, its less productive neighbor. That's the theory of absolute advantage. It's very plausible. It's also very wrong. To see why it's wrong, let's take another simple example. Here's a picture of Martha Stewart ironing her shirt. Now, let's stipulate that Martha Stewart has an absolute advantage in ironing. She has an advantage in ironing just like the United States had an advantage in producing computers and shirts in the previous example. In other words, we'll stipulate that Martha Stewart can iron a shirt better and in less time than anyone else. So, if Martha Stewart has an absolute advantage in ironing, should Martha Stewart iron her own shirts? And of course the answer here is no. Why not? Well, every hour which Martha Stewart spends ironing her shirts is an hour she's not spending doing something else which is even more valuable, running her own business, for example, running her billion-dollar business. And in fact, in a famous statement, Martha Stewart, because she's very wise, she said, "I don't always do all of my own ironing, even though I wish that I could." Let's take a little bit more detail about why it doesn't make sense for Martha Stewart to iron her own shirts. The most important point to remember is that the important cost is opportunity cost. So what is the opportunity cost to Martha Stewart of spending an hour ironing her own shirts? Well, it could be thousands of dollars, at least. Martha Stewart will be better off if she specializes in producing her television show, and then she trades with someone else who has a lower opportunity cost of ironing. It doesn't make sense for Martha Stewart to iron her own shirts because the cost of her doing so is devoting her time to something where she's even more valuable, where she's even better, and that is producing her own television show. So Martha Stewart has a comparative advantage in running her business. Or to put it slightly differently, she has a comparative disadvantage in ironing. The cost to her of ironing is very high precisely because she is so much more productive at other tasks. So Martha Stewart wants to specialize in what she is most best at, in where she has a comparative advantage. Other people are almost as good as her at ironing clothes, but they're not as good at her at producing her own TV show. So that's why Martha Stewart shouldn't iron her own shirts. Let's go back now to our previous example of the United States and Mexico. So the key to comparative advantage is understanding opportunity cost. So let's take this previous figure we had from a previous slide and turn it into an opportunity cost figure. So remember what this top figure tells us. It tells us, for example, that in Mexico it takes 12 units of labor to produce one computer, and in Mexico it takes 2 units of labor to produce one shirt, and so forth. Okay? For the United States, it just takes 1 unit of labor to produce either a computer or a shirt. Okay. Now, let's begin with an easy case. What's the opportunity cost of one computer in the United States? In other words, to produce an additional computer in the United States, what would we have to give up? Well, in order to get that additional computer, we'd have to take labor from shirt production and move it into computer production. And in particular, we'd have to take 1 unit of labor from shirt production and move it into computer production. That would get us 1 more computer at the cost of 1 shirt. So the opportunity cost of 1 computer in the United States is 1 shirt. Well, what's the opportunity cost of a shirt? Well, the opportunity cost of a shirt, what you're giving up to produce an extra shirt, is 1 computer. Okay. Slightly harder case. What's the opportunity cost of 1 computer in Mexico? So in Mexico, in order to get an additional computer, you'd have to transfer labor from shirt production into computer production. Okay? But how many units of labor you need to transfer? You need to transfer 12 units of labor. In order to get 1 computer, you're going to have to take 12 units of labor from shirt production. That means how many fewer shirts? Since it takes 2 units of labor to produce 1 shirt, and you've got to move 12 units of labor, it means that the opportunity cost of 1 computer is 6 shirts. If you need an additional computer, it's going to cost you 6 fewer shirts in order to get that computer. And going the other way, in order to get an additional shirt, you're going to have to give up 1/6 of a computer. Okay, so now we have our opportunity costs. And now it's actually pretty simple, because what the theory of comparative advantage says is that you should produce what you can produce at lowest cost. Okay? So who here has the lowest cost of producing a computer. The lowest cost of producing a computer is the United States. The United States is the low opportunity cost producer of computers. Now, who is the low cost producer of shirts? Well, it's Mexico. In Mexico, you're only giving up 1/6 of a computer to produce a shirt. In the United States, you're giving up one computer to produce a shirt. So you'd much rather produce shirts in Mexico where the opportunity cost is lower. Okay, so what we're learning here is that Mexico ought to specialize in computers because they're the low-cost producer of, in shirts, because they're the low-cost producer of shirts. The United States ought to specialize more towards computers because they're the low-cost producer of computers. Let's look in more detail. So I'm going to leave some of the details to you, actually, in some homework questions, which we'll go over in a future video. So question 1. Let's suppose that Mexico and the United States each have 24 units of labor, and that they each devote 12 units of labor to producing computers and 12 units of labor to producing shirts. That will be our baseline scenario. So the question is, what is total world production in this scenario? That's question 1. Question 2. Suppose that Mexico specializes in producing what it produces at lowest opportunity cost. We just saw that with shirts. And suppose that the U.S. transfers 2 units of labor from shirts to producing what it produces at lowest opportunity cost. That's computers. What it then is total world production. Finally, can trade make both countries better off? And here what I'd like you to do is give a concrete example of how many units have to be traded from where to where in order to make both countries better off, if that in fact is possible. So to help you along a little bit, I know that was a mouthful, let's take a look at this in terms of a diagram. To help you along, I want you to fill in these tables. So our basic table from which you're going to draw the information is up here. If both countries have 24 units of labor, half devoted to computers, half to shirts, there's no trade, so production is equal to consumption in this first example. What is production going to be? So Mexico, 12 units of labor for computers, 12 shirts. How many computers, how many shirts? Same for the United States. How many computers, how many shirts? What's total world production? Then suppose we have specialization. What's production going to be? So Mexico has 0 units of labor in computers, 24 in shirts. The United States has 14 units of labor in computers, 10 in shirts. What's production in each case? What is the total for the world? And then finally, can we, with production with specialization, can we now find a way to have trade which makes both countries better off? And what's the exact, or what's a exact price ratio at which that trade will occur? We'll take that up in a later video. Let me just finally give you some concluding comments on comparative advantage. I want to conclude with a caution, but also a big picture view of comparative advantage. In the 2 country-person examples I've been working with in order to explain the theory, everyone is made better off by trade. In larger examples, trade will increase aggregate wealth, but some individuals can be made worse off. And that should make perfect sense. After all, if A and B have been trading, and then because tariffs fall or because transportation costs fall, if A starts trading with C, then B may be worse off, even though A, B, and C together have greater aggregate wealth. That's just a caution to keep in mind. Now here's the big picture. Comparative advantage. It applies to people, to groups, to countries. It's sometimes called the law of association. And it's not only a beautiful theory, it's a very positive and optimistic theory, because it says that we all have something to gain from trade. It says by working together we can increase total wealth. Moreover, we can I like to phrase this in terms of a politically correct slogan. Diversity is strength. You've probably heard that slogan before. What comparative advantage adds to this is that diversity is strength when combined with trade. It's trade which turns diversity into strength. That's really the bottom line on comparative advantage. We'll be saying more in future videos. Thanks. Okay, so in this lecture, I'm going to give you the answers to the homework question. So make sure you've done your homework question. No cheating now. Won't help you with the cheating. All right, let's take a look. So remember, our basic data is in the top figure right here, and we want to now answer, suppose that there's 24 units of labor, 12 devoted to computers, 12 to shirts. How many computers and shirts in Mexico? How many in the United States? Okay. Well, if Mexico devotes 12 units of labor to producing computers, and it takes 12 units of labor to produce one computer, then you're going to get one computer. In Mexico, it takes 2 units of labor to produce one shirt, so if you devote 12 units of labor to shirt production, you're going to get 6 shirts. United States, even easier, because it just takes 1 unit of labor to get one computer, 1 unit of labor to get one shirt. Therefore, if you devote 12 units of labor to computers, you get 12 computers. You devote 12 units of labor to shirts, you get 12 shirts. So the total world production of computers is 13 computers, and total world production of shirts is 18 shirts. Okay. Now let's suppose that Mexico specializes, puts all of its labor, 24 units of labor, into shirt production, 0 into computer production. How many shirts and computers now? Well, clearly 0 computers. Shirts, we now have 12 shirts, 24 units of labor, 2 units of labor per shirt, so you get 12 shirts in total. What about the United States, which now devotes 14 units of labor to computers, 10 to shirts, again because it's 1 unit of labor per computer, 1 unit of labor per shirt, then we simply get 14 and 10. Now here's a key. Look at the totals. We now have 14 computers, okay, and 22 shirts. So total world production has gone up. We have more computers with specialization than we did when the two countries were not specialized and did not trade. Here we have 13 and 18. Now we've got 14 and 22. Big increase. Now notice, however, that Mexico doesn't have any computers, okay? And the United States has fewer shirts than they did before. So, is there a way to make both countries better off? Well, clearly, since the total production has gone up, there is. Let's take a look at how. Here again is consumption with no trade. Here is production with specialization. Now suppose that the United States trades 1 computer to get 3 shirts. There are other possible trades which make both countries better off, but this is a nice simple one. So the United States trades 1 computer. Remember, it produced 14. It trades 1 computer to Mexico. So the United States now has 13. It gives 1 to Mexico. Mexico has 1. In return for 3 shirts, so the United States used to have 10 shirts. Now it gets 13. Those extra 3 shirts come from Mexico, which produced 12, but now Mexico only consumes 9. So now let's take a look. Total production is the same, okay, but notice what has happened to consumption with specialization and trade compared to when there was no trade. So when there was no trade, Mexico consumed 1 computer and 6 shirts. Now they're consuming 1 computer and 9 shirts. So Mexico is better off by 3 shirts. Okay. The United States was consuming 12 computers, 12 shirts. Now they're consuming 13 of each, so they're better off. The United States is better off by 1 computer and better off by 1 shirt. Pretty remarkable. Trade, according to Comparative Advantage, has made both countries better off. One thing to keep in mind here is that absolute advantage, although it doesn't explain trade, it does explain how wealthy countries are. So even with trade, notice that Mexico is still considerably less wealthy than the United States. That is, total production in Mexico is 1 computer and 9 shirts, compared to the United States with 13 computers and 13 shirts. So absolute advantage does explain which countries in the world are rich, or one of the aspects of which countries in the world are rich. But comparative advantage explains why it makes sense to trade and what goods it makes sense to trade. And for more on this, I invite you to take a look at my textbook with Tyler, Modern Principles of Economics. Thanks.
We've already considered some of the theory of comparative advantage, so now let's take a look at the evidence on gains from trade. Plenty of articles show that trade and economic growth are positively correlated. That is, they move together. But it's hard to separate out how much is trade causing growth or how much is growth causing trade. So ideally what we would like is some kind of natural experiment where there is an exogenously given increase in the amount of trade, and then we can see how much economic output responds. And for such an experiment, we can turn to the earlier history of Japan. Japan had instituted fairly tight seclusion policies since 1639. In part, they were afraid of imperialism, and also they were afraid that Christianity would obtain a foothold in their country. So for over 2 centuries, there was really just a very small amount of foreign trade entering Japan. But then, for political reasons, come 1859, Japan is suddenly opened up to trade, and after that point, trade is mostly free. This is possibly the kind of natural experiment we've been looking for. One benefit of the new trade is that Japan was able to export to the rest of the world, and at that time the 2 most significant Japanese exports were tea and silk. The new trade is also a story about imports. For instance, in Europe, due to the Industrial Revolution, cotton textiles had become much cheaper than they were in much of Asia. Iron production also was much more efficient in, say, England than in Japan at the time. Japan was able to gain from trading for the goods, but also over time trading for those technologies. Japan was also able to import a lot of new goods that they simply hadn't had before, and this includes glass, boots, butter, woolens, and also muskets. So the question asked in one research paper is this: for the years 1851 to 1853, how much extra income for Japan would in fact be equal to the gains from trade that Japan enjoyed from opening up trade with the rest of the world? In essence, this question is trying to measure the benefits from the much freer trade. A simple way to think about what's going on is that we're trying to add up the gains from the Japanese exports and then sum those with the ability to bring in cheaper imports, again through trade. These measures, of course, are somewhat inexact. For instance, measuring the value of exports and imports is based on market prices, but market prices, as we know, they only measure value at the margin for the final increment of a good or service which is traded in the market. Also, this is a study of the middle of the 19th century, and the data are to some extent incomplete or imperfect. Finally, it is hard to value new goods using this method. So we do have data on the price of new goods in the post-trade regime, but from that we're somehow trying to extrapolate what was the value of those new goods in the pre-trade regime, and that can be hard to do. Still, for all of these problems, we are getting some reasonable measure of the gains from freer trade here. And what is found in the study is this, that there is an upper bound which we can measure on the gains from trade, and that upper bound at the time was about 8 to 9% of Japan's GDP. Perhaps most importantly, there is a longer-term dynamic gain from having this trade. That is, over time, it enabled Japan to develop and become a modern country, as for instance is shown here. This is a picture of Yokohama and Mount Fuji. Had Japan not opened itself up to trade, this eventual brighter future for Japan probably would not have been possible. And this is not captured in that number, that upper bound of 8 to 9% of GDP. The main results here are drawing on a very good and important research paper by Daniel Bernhofen and John Brown, and that is called Empirical Assessment of the Comparative Advantage Gains from Trade, Evidence from Japan. Those same 2 writers have another piece, somewhat more technical, called A Direct Test of the Theory of Comparative Advantage, the Case of Japan. If you'd like to read about the history of Japan's opening up to trade with the outside world, one place you could start is simple to Google Opening of Tokugawa, Japan. Hello. In this video we're going to review the basics of trade, talking about issues such as comparative advantage, specialization, and we're going to start this example by assuming we have two countries, the United States and Japan. Each country can produce two goods, grain and steel. The United States production possibilities frontier is given up here in the top left. If we allocate all our resources to producing nothing but grain in the United States, we could produce 100 units of grain. If we allocate all our resources to the production of steel, we could produce 50 units of steel. We're going to assume that the United States will produce a combination of grain and steel where we're producing 60 units of grain and 20 units of steel, a point on the PPF curve. Japan likewise can produce grain and steel. If Japan allocates all its resources to grain production, it could produce 40 units of grain. If it allocates all its resources to the production of steel, it could produce 40 units of steel. We're going to assume that Japan locates on its PPF at a point right here, highlighted by this point, which corresponds to 30 units of grain and 10 units of steel. Usually the first thing we want to do in these types of problems is figure out who has a comparative advantage in which good. The way to do that is to construct a simple table like I've shown here. And we're basically trying to calculate the opportunity cost of producing one more unit of something. In this case, one more unit of steel and one more unit of grain, the two goods in question. So in this first column here, I have the opportunity cost of producing one more unit of steel. In the United States, the opportunity cost of producing one more unit of steel is going to be 2 units of grain. In other words, every time we produce one more unit of steel in the United States, the cost comes in giving up the opportunity of producing 2 units of grain. The way I calculated that answer is by using that formula that I talked about in the previous video, where we take what you give up and divide it by what you get. In the United States, what we give up in producing steel is 100 units of grain. What do we get? 50 units of steel. So 100 divided by 50 is where the answer 2 is coming from. In Japan, we're going to calculate the opportunity cost the same way. In Japan, what we give up if we're producing steel is 40 units of grain. What do we get in return? In Japan, if we give up producing 40 units of grain, what do we get? 40 units of steel, so 40 divided by 40 is just 1 unit of grain. So maybe I'll just write that here. And that's where the 2 came from. Now, to examine the opportunity cost of producing the other item, in this case grain, it's what you give up divided by what you get. If we're producing nothing but grain in the United States, we're giving up producing 50 units of steel. What are we getting back? The 100 units of grain. 50 divided by 100 gives us the opportunity cost of 1/2. Every time we produce one more unit of grain, in other words, we give up producing 1/2 unit of steel. For Japan, if we're producing nothing but grain, we are producing, we're giving up producing 40 units of steel. We're getting 40 units of grain, so the opportunity cost is 1 unit of steel. Every time we produce one more unit of grain in Japan, we always give up producing 1 unit of steel. So given these values, these numbers, we can now calculate comparative advantage. So let's see who has a comparative advantage in which good. In terms of producing steel, it looks like Japan has a comparative advantage in the production of steel. Every time Japan produces one more unit of steel, it only gives up 1 unit of grain. But the U.S. gives up 2 units of grain. Therefore, Japan has a comparative advantage in steel production. So let me note that here. Japan's comparative advantage, CA, is in steel production. 1 is less than 2. Now let's see about the production of grain. Who produces grain at the lowest opportunity cost? Well, it appears that the U.S. has a comparative advantage in grain production. Every time you produce one more unit of grain in the United States, you're only giving up 1/2 unit of steel, while in Japan you would have to give up a full unit. So the United States U.S. has a comparative advantage in grain production. In these problems, then, generally what we're going to do next is we're going to assume that each country is going to completely specialize in their comparative advantage, and then they're going to trade with the other country for the good that they don't have a comparative advantage in. So let's go through that analysis now. To finish up this video, I want to show how both countries can benefit from comparative advantage, specialization, and trade. We're going to have a table here at the bottom with several columns. The first set of columns shows the situation should be without trade. Let me put over there. Without trade. Assuming that the United States and Japan are self-sufficient, not trading with one another, we can assume that the U.S. is going to produce and consume 60 units of grain and 20 units of steel. We're also going to assume that Japan is going to produce and consume 30 units of grain and 10 units of steel. Note at the beginning of the video I illustrated where those points were located along the production possibilities frontiers. Now we have a next set of columns here that I'm calling the specialization columns. You can assume that each country is going to specialize in their comparative advantage. In the United States case, they're going to do nothing but produce grain. Grain, after all, is what we argued is what the United States has a comparative advantage in. So the United States will produce 100 units of grain, and if the U.S. is producing 100 units of grain, can't produce any steel. Japan is going to specialize in its comparative advantage, which we argued is steel production. So Japan at most can produce 40 units of steel, and if it's producing 40 units of steel, it can't produce any grain. Now what we want to do is to come up with some terms of trade that will basically make both countries better off. So one such terms would be that the United States trades 35 units of grain for 25 units of Japanese steel. So once again, the terms of trade might be that the United States is going to trade 35 units of grain for 25 units of Japanese steel. So if the United States trades away 35 units of grain, it'll have 65 units of grain. Just simply 100 minus 35. What does the United States get back? Well, according to the terms of trade, it'll get back 25 units of steel. Now, from Japan's perspective, Japan is receiving 35 units of grain. Okay, it wasn't producing any grain while it was specializing, so it's going to get 35 units of United States grain. What does it cost Japan to do that? Well, Japan has to trade away 25 units of steel. So 40 minus 25 is 15. Let's examine these trade numbers here at the end. With trade, the United States is consuming 65 units of grain and 25 units of steel. What's interesting about that point, it's going to be a point outside the United States production possibilities frontier. With trade, a country can consume beyond its PPF. Japan, the same thing. This consumption point of 35 units of grain and 15 units of steel is going to be a point that is outside Japan's production possibilities frontier. Trade allows us to have a much larger level of consumption than otherwise would be the case if we were simply self-sufficient. The last thing I want to do in highlighting the benefits of trade is to show you that the U.S. is buying a unit of steel for 35 divided by 25, what you give up divided by what you get again, for only 1.4 units of grain. So the U.S. is buying a unit of steel, in essence, for 1.4 units of grain. If the United States was self-sufficient and didn't trade, it would cost the United States 2 units of grain to produce 1 unit of steel. So the United States is clearly benefiting from this. It's cheaper for the United States simply to buy steel from Japan than to produce it for themselves. In Japan, the same thing. Japan is buying 1 unit of grain for 25 divided by 35, what you give up divided by what you get, or 0.71 units of steel. It costs Japan 1 unit of steel to produce 1 unit of grain. So it's simply cheaper for Japan to get its grain from the United States than to produce it for itself. Okay, I hope you found this video helpful.